Good morning, everybody. Good evening. Can you hear us? Can you give us a thumb up if you hear us well, please? Rahul, can you say something?
Hey, good afternoon, good morning, good evening, wherever you're at.
So, what about the sounds, folks? Can we go on? Waiting for... Yes, we all good. Okay, so welcome everybody for yet another workshop. So this time, this is the third of a series where we talk about event-driven toolkit, all prepared with love by Rahul. I'm so happy to have you back with us today. And we do have a lot to cover again today, I guess, right?
Yes, absolutely. It's like we're trying to boil the ocean today. Well, hopefully we won't.
Of course not. So today we will discuss a lot about Spark, Spark streaming, Kafka, Cassandra, and Astra. So now, Rahul, you are sharing your screen.
And the presentation should be coming up in a second.
It's loading.
Thank you, Google, for your high-speed internet. There we go.
I can see it. Yes, here we are.
All right. Hey, Cedric, thank you so much for having me again to do the Spark streaming with Kafka, and we're actually going to cover some Spark batch as well. I'm really excited because Spark is it's like a Swiss Army toolkit. You can do everything with it. But when we combine it with Spark, when we combine Spark with Cassandra and Kafka, we can do a little bit about myself.
Please.
I'm a CEO of a small consulting team. I've also helped create Cassandra.link, which is a knowledge base of all things Cassandra, and I maintain it's a README, but basically the best resources that you should need to know about Cassandra. I curate them, and I have a couple other awesome ones as well. These days, since meetup groups are no longer in person.
That's cool, like that, to meet all experts.
And this is the Menti code. If you didn't know, keep that.
Yeah, we jump into Menti right away.
All good. So this is part of a series, and the first couple of topics we covered were basically what is REST, how is that related to event-driven systems. We actually built an API on Cassandra. We'll quickly take a look at it. And even though Astra comes with its own REST API and GraphQL API, a lot of times you want to do some processing before we save it into Cassandra. So that's why we have our own custom API in Python and Node. Then the next webinar we did was how to use Kafka in different ways to event source the information for a particular event, and then use a processor to process that event information using a consumer. We actually connected Kafka to Cassandra using Kafka Connect and K-streams. And today we're going to connect Kafka to Cassandra with Spark streaming. And then once the data is in Spark, in Cassandra, we'll do some special processing. This setup of Cassandra, Spark, and Kafka is a very, very basic setup, and our goal is to give you a toolkit. Today, we're going to review basically, the Kafka setup, the Cassandra setup that we have in our Git pod. We'll make sure that those, systems are up and running. If you want to follow this, we're assuming that you've done this, the other two webinars with us before, and you have the Cassandra API and the Cassandra real-time Git pods up and running with an Astra account. If you don't, that's okay. Just follow along. Watch what I'm doing. All of this stuff, as you'll notice, is on GitHub, and you can do this anytime. If you haven't used Gitpod before, you'll see that I'm doing everything in the browser. You don't have to download any code and run it on your computer, or make a cloud server. Everything is serverless. Once we test everything, we're gonna have a quick Spark streaming job that's going to take data off of Kafka using a structured stream. It's going to select some information, and it's going to materialize a table in Cassandra. And once data is in that table, and actually looking at another data set, we're going to have a batch job that takes all the data from Cassandra, crunches it, and then saves it back into another table. These are some basic patterns that we see in the Kafka Cassandra Spark ecosystem. Generally, that we end up using different ways to stream data into Kafka. We use different ways to stream data out from Kafka into Cassandra. And when we need to do some really heavy crunching of information or analytics or machine learning, we end up using Spark. Hopefully, at the end of today, you're going to have a basic understanding of Spark streaming in the context of Cassandra and Kafka, and you'll know how to run a streaming job in a Spark batch job. I want to thank DataStax for being a great sponsor and partner, and giving Cassandra as a service for free, so you don't have to set up your own Cassandra, for doing these events. And Gitpod, thank you, Gitpod. I have my sticker that I got from you guys.
Oh, lucky you! I need those stickers as well.
Make this code, they've given us free pro account, so thank you for the sponsorship. And then Deloitte has also been helpful in beta testing this workshop in a couple of different times before we started doing it publicly. What is an architect? We at Not architect platforms in Cassandra and related technologies. An architect is a chief builder. In computing, it's somebody who designs or makes things. So we design and make stuff that basically runs on Cassandra and Spark and Kafka, which are related technologies. Love scalable fast data. Like literally what we're talking about today, Cassandra, Spark, Kafka, we love doing that. That's what we love doing. And we do things without DataStax, with DataStax. Sometimes the technology is slightly different, but ultimately Spark, Cassandra, and Kafka can be done in open source, or it can be done on cloud, it can be done on premise, or with commercial support from companies like Confluent and DataStax on different clouds. But the common denominator is we love doing scalable fast data, and that's what we're going to talk about today.
Great.
Go ahead, Cedric.
Okay, yeah, so as usual during this live workshop, we are on YouTube answering your question, and we try to answer your question on the spot. But if you do have long form question, troubleshooting, you should be interested to use Discord, okay, where we do also have expert analyzing what you are doing, and you can go to breakout rooms and discuss if you are really stuck. Today we used Menti already, so you know about that. And so we will use Cassandra, Kafka, and Spark. So the data will be stored in Astra. I will explain you what it is, and that's on the top. You see the link to the runtime. We will give you some time to register to Astra if you don't have any account yet. It's a free tier. You can go. There is 5 GB, which is much more than we need for today. And we will use 2 GitHub repo. The link are also in the YouTube descriptions, but I probably will give you the link again on the YouTube chat. And we will use Gitpod against each repo because we need a lot of power, Kafka and Spark is a lot of CPU, and using Gitpod and the virtual IDE they provide us, we do have one dedicated for the API and Kafka and another one for Spark, or one or the other. I don't know how you split workloads in the two, but we would need two, Rahul.
All right. So, just so that the Gitpod can get warmed up, we're going to go ahead and launch Gitpod. And the way you launch it is you just go to, go to the URL.
So let me share the URL with you all. I copy the link in the chat right now. Boom.
And once you get the Cassandra real-time up and running, you'll notice two Gitpod buttons. One is for Cassandra.api, which, as I mentioned, it's nice to have. You don't necessarily need it for this, but we're going to verify that Astra is up using this API. So, control click this button to open the Cassandra API in Gitpod, and then what we're going to do is you're going to scroll down a little bit until you find the second one to start Cassandra real time. And I think that here we go, where it says 2.
Yeah, and Rahul, don't hesitate to make your screen, the screen bigger on README. Just increase the font size for everyone.
Yeah. Let me do that right now.
Yeah, great.
Looks like a little bit better. So when we bring up our GitHub URL in Gitpod, all we're really doing is just saying, hey, open up using this URL. It's going to first ask you to log in. You can just use your GitHub login. And what it'll do is it'll actually save that workspace. It's building a container right now for us and pulling down our code and getting everything up and running all on the web. So we're going to let this kind of bake in the background. It takes a few minutes for it to start up. And we're going to continue on with the rest of the presentation. The first section of the presentation we're going to talk about is, why are we doing this? This code base that we're showing, what is the purpose of this code base? And I personally like to learn, programming or technology if I know where there's a reason behind it, right? Sorry about that. And wow, Google, it's either my Google or it's my internet. It's taking a second here. I might just not do the full presentation mode going forward.
Yeah.
So, when you open up Gitpod, it's going to look something like this. It looks like basically Visual Studio. It's not Visual Studio. Actually, it's Thea, which is an open source clone of Visual Studio. And it's the editor, it's the server, it's kind of everything all in one. So why are we building this? Well, right now we have a platform that helps us generate the Cassandra.link website. And we have the ability to generate many, many more websites because our knowledge base has probably 20, 30,000 links in it. The Cassandra knowledge base has about 9, I think it's about 1,000 to 1,500 links in it. But it's a platform where we curate knowledge, and there's an admin screen. There's kind of like an advanced view to look at this on MySQL and PHP, and we have a mirror of that data in Cassandra, and we have a mirror of that data in Solr. And we wanted to make this scalable. We wanted to make this go bigger. So what we decided was, let's see if we can take this whole platform and make it serverless. All right. And so the front end of this application is using the Jamstack. And there's an amazing workshop happening tomorrow about React and the Jamstack, and the CEO of Netlify will be there. So we use Netlify to host interfaces, both that talk to APIs, but also we generate using Gatsby a full website. So all of the 1,500 pages plus, they get generated out, but it runs off of an API. So we want to migrate that API. This part of the system is already serverless because it's using Vercel and Netlify. The search stacks is a hosted Solr serverless. We don't really worry about it. And right now, we want to stop managing our own API. We want to eventually go to Astra, because Astra gives us basically an API in GraphQL. It gives an API in REST. It's going to have other cool stuff. And if we have any particular special needs for an API, we'll probably host them on like a Kubernetes, a managed Kubernetes, so that can be a serverless Kubernetes. We also want to make this event-driven. Right now, the system is not event-driven. The whole process of these talks has been to show how do we build an event-driven system. And then after data comes in event-driven and it's updated event-driven, we also want to have some processing of the data itself, and you'll see what type of data it is. It's websites, right? We want to do some special analysis of the website data and see if things are correlated using machine learning. There are two Git pods. One, which is the Cassandra API, and there's parity between Leaves API Python and Leaves API Node. If you look at the code, they're basically doing the same thing. They're just slightly different. The only reason we have an API separate from the Astra API that already exists for you is that when we were first building this out, that REST API wasn't out because we were one of the first users of Astra. And then once it was out, we realized that we still needed to do some custom scraping, right? So we still need to have our own API layer. Even if we use these, even if we piggyback off of these, we need to have our own. The Git pod we're looking at today, in the last talk, we covered the Kafka aspects of it, right? So we run a Kafka broker, we have a registry, we have a REST proxy, we have Kafka producers and consumers that can talk to this. There's a Kafka GUI powered by AKHQ that'll show us the topics in there. And today we're going to be looking at this, right? The stream process that takes data from Kafka, puts it into Cassandra, and a batch process that reads from Cassandra, processes it, and puts it back into Cassandra. Quick overview of REST versus microservices. If you haven't been here on this talk before, this is either going to be too much information or it's going to be just right information. I apologize. We just want to give everybody context. Microservices are loosely coupled. They can be written in basically a variety of different ways. People can coordinate them using asynchronous technologies like AMQP protocol or Kafka itself. Or they can do everything synchronously using REST. For us, just looking back at this, each of these things right here could be a microservice if we make it loosely coupled, meaning this is not dependent on this and this is not dependent on this over here. So what we have today, at the end of today, is you can consider this could be its own microservice, this could be its own microservice as these APIs and the stream process as well. The point being that we can do a combination of synchronous and asynchronous processing of events on the same platform. The only thing that we generally don't follow from the conventional microservice thinking is that each service needs its own DB. And that's not true in the Cassandra world. The reason is that Cassandra can scale to thousands and hundreds of thousands of servers. And you can think about a key space or a table like its own kind of microservice that scales on its own. So because we're on Astra, which can infinitely scale, we don't have to worry about a different database or a different key space or table per microservice. Even though we're doing some of that here, we're not going to make another Astra database when we add new functionality. We can just make another table.
Yeah.
So generally in the Cassandra world, what you have is you can have one Cassandra cluster and you can have several microservices being powered by different key spaces. Another cool thing about, and this is more on the data stack side, is that you can bring data into Cassandra and retrieve it out as JSON and vice versa. In the later version of data stacks, there's DSC Graph 6.8. You can add data using graph queries and then retrieve data using CQL.
Yeah, so a word on the microservice, maybe with Cassandra. You might have heard that in a microservice world, there is one database per microservice to avoid any resource sharing and any coupling in between the microservice. And I would like to challenge a bit that. So first, when you hear that you cannot have the same database, it's really not the same. It doesn't mean it should not be the same installation of the database. Okay, as long as you can have a proper handling of your resource, you're good to go. And in a Cassandra cluster, you can have first multiple data centers. So depending on where you are, where is your location, you can have some nodes in Asia, some nodes in Europe, some nodes wherever you like to reduce the latencies. So first you can split the workload in data centers. That first thing. Then in Cassandra, you have a key space, which is like the schema for Oracle. And what it tends to do is one key space per microservice, because at the key space level, you will define where the key space live, on which data centers, how many times does the data is replicated, stuff like that. But not only that, in Cassandra, you can also split by tables, okay? In the tables, there is no join, no integrity constraint. And so what you do most of the time is have a dedicated table for your dedicated query. That means a microservice in charge of a bounding business context would be in charge of a limited set of table. And it's pretty clear to see what is the scope of this microservice, because now you don't need to do joins or anything like that. There is no joins in Cassandra. And so with the same Cassandra cluster, you can split by data center, key space, table, query, and then of course you still have airback. And when you execute, when you fire a query against Cassandra, the load will be distributing among the nodes for you. Okay, so the coupling is minimal.
Absolutely. And by the way, what you just said, Cedric, I have had to explain the same thing every time I've talked to somebody who's done microservices not on a scalable data store. They've done, with Mongo or MySQL or Postgres. They always come back to, well, what about the DevOps aspect of this? What about the infrastructure? I tell them, look at Cassandra as a infrastructure itself, right? And when you think about creating a new database on a new database instance for MySQL because it needs to be powered enough so it can scale, and you need to vertically scale that. Generally, you're going to have to start sharding that database on MySQL if it starts to grow. Well, with Cassandra, if you just think about that infinite data store at the key space level, you can grow it as big as you want. It doesn't really matter. And from a DevOps perspective, you can have key space blue, key space green, right? If you want to do blue-green, or even at the table level, you can have different schemas on the same table because Cassandra, it's a NoSQL columnar data store, which means that you can have two schemas that don't overlap, and that data is not replicated. It's just whatever you're setting is going to get set on the cluster. We can go so much into that discussion, but Cassandra is awesome for microservices. Jeff Carpenter has an amazing article and a couple of videos about this as well. Just Google microservices on Cassandra and you'll find his article.
And even a book. And if you saw the definitive guide of Cassandra in the datastax.com website, you would see a link to get a free copy of the book. But for this one, I won't give you the link. Go to the datastax.com and look around, look for a book, and you will see a couple of books with a free download link.
Excellent. So one of the patterns of software that people implement with microservices is event sourcing and CQRS. CQRS stands for Command Query Request Segregation. Also, people say Command Query Separation. But basically, it's a way to scale systems. So when an update comes, it's an event, and a processor basically saves that data to potentially different places. One for the event itself, one for where the data is going to be queried. And for example, if you were not using DataStax and you did not have a built-in search with DSC search, and you needed to materialize that data in both Cassandra and Elasticsearch, your event processor would take that event and it would save it in both places. And Astra has a search index using the new advanced search SAI, but it's not as powerful. For example, like Elasticsearch, Lucene is a very, very powerful search index. So in that case, you can still save to Astra, have some basic indices, but then simultaneously save that into Solr or Elasticsearch or a third-party cloud provider like Algolia or SwiftType. You name it. There are so many different third-party cloud search providers now. The other is that when we update data and when we retrieve data, those are seen as two different types of requests, right? When we retrieve data, we're getting a report, we're getting a data set. When we're updating data, it could be updating various different things. And especially in the NoSQL world, we often materialize different sets of data for fast retrieval. That's one of the data modeling trainings on DataStax Academy. It talks about the ideal is to have one partition per query. Now that partition may have multiple rows, but you may have multiple tables to represent different types of queries. So using event sourcing, we can send one event and then process it and save that data into several different places. So let's talk a little bit about Spark. What is it? How to use it, why to use it, when to use it. Apache Spark is probably the second or third generation at this point. Yeah, it's Spark 3.0 now. And if you, I'll show you at Google Trends. Apache Spark is the de facto way to do big data now. Pretty much. You can do other types of technologies for fast data, but Spark is kind of the name. There are a lot more people that still use. There's a lot of people that still use, Yarn and MapReduce, but you can use Spark on top of Hadoop. So they're not mutually exclusive. People use Hadoop, HDFS, and then they use Spark alongside it. What is Spark? It's a collection of technologies. Just like Kafka has a bunch of stuff that runs on top of it to make it Kafka. Apache has essentially a core, and on top of the core, we have Spark SQL, which is a Hive-compliant way to query data in Spark. Well, how to get data in Spark? You bring it into a data frame, or you can map a Hive table or a Spark SQL table to like a Cassandra data store, and you can do queries on Cassandra. You can do joins on Cassandra tables using Spark. Spark streaming, this has gone through a couple of different iterations. It's a way to stream events off of various different types of queues. You can also have structured streaming, which means that when you get the event, it looks like a table, essentially. And we're going to look at that code later. We have machine learning built in, and there are extensions to machine learning libraries that you can run on top of Spark. And then graph, which now we have graph frames, basically to do graph processing with, like if you wanted to do the PageRank algorithm, you could do it in like 5 lines in graph on top of Spark. When we make a Spark job, what we're really doing is we're creating a directed acyclic graph. A directed acyclic graph, you're going to find this term in several places, things like Airflow will talk about it. But basically, directed means it's one way, right? The graph is going one way. There's no loops in the graph. Acyclic directed means that it has arrows. There's no two-way, but acyclic meaning that there's no loops in it, and it's a graph. It's nodes and edges. So we're creating a directed acyclic graph of the work that needs to be done, and we do that by writing Spark code. Spark actually does this work for us. It makes this. And what it does is it figures out how much of this directed acyclic graph needs to be run on which computers. So if we do it right, we can have the same Spark job running on one computer, or we can have it running on 100 computers. And that's the point at which Spark becomes a cousin, so to speak, or like a best friend of Cassandra and Kafka, because Kafka can scale to hundreds and thousands of servers. Cassandra can scale to thousands to hundreds of thousands of servers. Spark, I think the biggest one I've seen is about 1,000 node cluster of Spark, right? And the other cool part about Spark is that it can talk to a bunch of stuff. It can talk to any data store that you're looking to connect to. You can bring data in, you can send data to these different systems, and you can represent this data on these different systems in a similar way in data frames, or now data sets is a new term. It's a unified analytics engine, but I would say it's like a general purpose computing engine, distributed computing engine, where if you wanted to execute just tasks, you could use Spark, but you may find something else is a little bit more lightweight. Spark has this heaviness to it, which only makes sense if you're really going to do some big number crunching.
Yes, so just a word on the overall architecture. So we won't dig into much today about DataStax Enterprise, the enterprise product of DataStax, but in the same node, we do have Cassandra and Spark. So that means if you need to scale, so you can scale both at the same time. And Spark is what we call token aware. So when Spark needs to distribute a computation around multiple nodes on Cassandra, because Spark is aware of the token range, it can start up the executor, as you can see here in the slide, exactly at the good place to get the computation local with the data. And that's just the neat features of DataStax Enterprise. If you don't have that, you can still do it, but you do have a cluster for Spark and a cluster of Cassandra. You can do that as an open source as well.
Yeah, DataStax makes it too easy to do Spark with Cassandra. Like once you use it, you're just getting like, what? Maybe that's gonna be a follow-on. How to use DataStax for all of this stuff. But today, we're gonna talk about Astra, which is basically Cassandra as a service, and we're gonna use Spark. But Spark with Cassandra on the same node is very, very powerful. Before we end, I'll just show a kind of a comparison between if you were to do this on your own, how much work you'd have to do versus kind of using the DataStax ecosystem. When we make a Spark program, generally we have a driver, we have a cluster manager that allocates resources, and then we have different workers. So you'll see when we bring up Spark, we're going to bring up the master, and then that's going to be in standalone mode, and we're going to bring up one worker, right? Because we have GitPod giving us roughly, I think, 16 gigs of RAM, which I'm impressed how much we get. But if we wanted to, we could have thousands of nodes running, and as long as we connect the worker to that cluster manager, that cluster manager will see that as a new worker. Couple of things. So Spark SQL is a way to query data, update, and really join data from various different places. It has a built-in optimizer that once you write Spark SQL, it creates a Spark job, and it grabs the data and brings it back to you. You can think about a data frame, like if you've ever used pandas. A data frame is like kind of like a database in memory. And so Spark, when you deal with Spark, when you do operations on Spark, it doesn't do anything until you say, like, do this up. Basically, there's transformations and there's actions. But ultimately, it only does the work once you execute the group by or aggregate function or output function. Up until then, it kind of keeps this DAG. But a data frame is a place where you can have multiple kind of tables in one object, and you can do operations on the same thing. We're going to look at data frames very briefly, but just remember that data frames are like the newer way of doing things. RDDs, or resilient data sets, are the older way of doing things. And now there's something called data sets, which is the newer, yet still way of doing things. But all of these data frames, RDDs, they're just representations of your data, right? When you connect to Cassandra and you say, I want to select from here, what it does is it gets that data from Cassandra and brings it into memory in Spark. That's the way Spark does its work. When you update that data frame and you say save it, it first updates it in memory, and then it saves it back to Cassandra. Spark streaming is gone through, as I mentioned earlier, 2 different generations. Spark streaming has 2 ways of doing things. One is just basic Spark streaming, and another is structured streaming. We're going to be doing structured streaming. The main thing about structured streaming is that it gives you a schema, right? When you're getting the event from your stream, you're getting it as a row with columns, with the named columns. So you can do select from that stream, and you can do Spark SQL transformations on that data before you send it through, right? This is the type of stuff that's also available in Kafka streams, right, with K-tables. But when we're dealing with Spark streaming, and especially structured streaming, you have the power of Spark across hundreds of thousands of nodes where it can distribute the work if you need to. A common use case for this would be you have a model, like a machine learning model that you've made already, and you ingest a streamed event, and you evaluate that data using your model in Spark, and then you send it through. And simultaneously, what you can say is, go ahead and update my model with my positive evaluation. A couple of use cases. You may have heard of these companies: Uber, Pinterest, Netflix, eBay, Conviva. What do people do with Spark? I mean, everything. Tell me what they don't do with Spark. Used to be that we would say, ETL is Spark is not for ETL, and over time, Spark is used for ETL all the time. But people now do streaming ETL. They bring data in. They'll do ELT, right? Extract it, load it, and then transform it, which is kind of what we're going to do today to enrich information after it sits somewhere. It's got a lot of power. I can't do it justice in this workshop to tell you the power of Spark. Once you start using it, you'll understand that it's not it's not a kiddie tool. Like, it's not a toy. It's got a lot of power. Just like Cassandra and Kafka, you can use it, but it's really powerful when you bring these things together. And then finally, the Spark ecosystem continues to grow. There's a site called Spark Packages, where you can see just for the tags for data sources, there's like 61 different data sources that you can connect to. You can also go to the site and there's about 500 different packages just for Spark, right? But if you are in the Spark ecosystem without any of these packages, if you're using Scala, any Scala library is available to you, any Java library is available to you. There's also R, if you're a statistician or a data scientist. Sometimes people use R versus Python. Same thing with Python. All the things that you can do in Python, you can do in Spark. You just have to think about the distributed computing nature, meaning you don't want to have a long-running process on every worker. I mean, you have to think about it, but you can do it. And then recently, C# and F#, which are basically .NET languages, they also have a binding for Spark. And
oh, really? I was not aware. C#, F#, no, gosh.
Yeah, it's been there for a while. It used to be called Mobius, and then now it's just called .NET Spark. And then finally Kotlin, which is fairly new language compared to Spark and Scala. It's kind of new. It's kind of a release candidate right now. But if you're into Kotlin, you can check it out. Just remember that Scala and Python are the only supported languages to do read, evaluate, print loop, meaning you can just start up a shell and start programming in Spark and see things happen. And then SQL is available in a REPL as well, in the Spark SQL shell, as well as if you start the Thrift server, you can get data via JDBC. So you can connect a business intelligence tool like Tableau or Qlik or Power BI to a Spark instance. And imagine, right? You can bring all this data into Spark, and then once it's in there, you can look at it and you can do joins on it and view it via different tools. Spark also runs on basically anything. So it runs on Docker. I mean, we're going to be running it inside a Git pod Docker. There's Mesos, Kubernetes. You can run it basically anywhere technology runs. You can run Spark because it's Java. It's a JVM system, right? And these are just different ways to organize the cluster.
Just before switching, if you go back, so we told you that you can do JDBC over Spark. That's true. Spark SQL and JDBC drivers like Simba, for instance. That's still Spark. Don't expect real-time computation when you query 1 billion rows. Okay.
Yes.
Spark is mostly for in this use case mostly for OLAP queries, and the response time is about in few seconds, even minutes, depending on the volume. The computation is still distributed, but there are still a lot of data to move over the wire here and there. So it's cool for Tableau, but pre-computed dashboard.
Yep. Yeah, and it depends on the BI tool that you use. A lot of these tools will cache the results, and they'll pull the Spark SQL to get this information. But if you have a lot of juice, you have a lot of machinery, a lot of memory, you can get pretty fast results. You just have to have like terabytes of memory in your cluster.
Yeah. You need power.
You need power, exactly. This I found interesting. I just was curious to see, Spark versus big data versus, machine learning. How has it come in terms of how the world sees this stuff? And, notice that machine learning has always been around. Well, not always. It's been around, and it was more popular than big data and Spark, right? This only goes back to December 2008. But around, I would say, 2010 or 11, big data started to take off was much more popular, and then Spark was like slow and steady, and here it comes, right? Here it comes, and it's now more popular than big data. And machine learning, people can do with it or without Spark, but I'm just fascinated how Spark as a term, Apache Spark as a term, is more popular than the term big data, because we do big data with Spark, right? Really interesting what you can find on Google Trends.
No more pig or yarn or hive. No, Spark is everywhere.
Yeah. So Cedric's going to talk a little bit about Astra.
Yeah. So let's. Yeah.
Yeah.
So can you move to the next slide? Yeah, I think I would explain everything in a single slide. So really, Astra, in top of your mind, should be a data platform as a service available in the cloud with Cassandra at the core and tons of tools to help you build app on top of Cassandra. So API, monitoring, web console, kind of IDE to shape your queries, stuff like that. So it eliminates all the operation because it's software as a service. It secures your data because now you access them through API and Airback. And it simplifies your development because with the API now you can use either a document API and use Cassandra like Mongo, or don't do that in data modeling. Okay, that's technically feasible. Or pretty easy to generate API on top of tables. And if you go to next slide now, so yes, so at the core, yes, you see Cassandra running multi-cloud. Okay, when you will start your instance later, on the free tier, I think you are limited to Google Cloud, but Astra can run on any cloud. Okay, and you can spawn some instance on the region you like. And it's high availability, of course, that's the natures of Cassandra. And on top of the database, there are some tools. So Astra is not only a database as a service, it's really a platform. So providing API, REST, GraphQL, a console, the studio, a data loader, DS bulk, and maybe and soon another tools coming. And if you want to automate the provisioning of the database, now you do have the DevOps API. The database expose the metrics, and if you're really into Kubernetes, you may have heard that we push pretty hard the Cassandra initiative with Cassandra running in Kubernetes, with the operator and all the tools I introduced in the beginning. Well, now with the service broker, you can tell Kubernetes to spawn your Cassandra instance directly into Astra. That was Astra service broker exposing the resource needed for an external kube cluster to run the pod, spawn the resource directly into Astra.
That's amazing. The whole service broker idea is cool. But
yes,
having Astra available in the cluster, in the Kubernetes cluster, is really.
And you can create an instance for free 5 GB, free forever, not limited in time, and we will never ask you the credit card. It's really free.
Definitely, definitely. Very, very cool stuff. I think you went over this, but
yeah, very, very quickly. So you can interact with Cassandra using the Cassandra query language, and this is what we did in the first session, or using the API. You do have the tools and look at all the drivers available. So that's to communicate to native SQL with Cassandra. In Astra, you now also have the API, REST, and GraphQL. But hey, drivers are still pretty efficient, and most people still use the driver, especially the Java one.
Definitely, the Java one I think is probably the most widely used. I mean,
Yeah.
Cassandra Spark connector uses it inside, so definitely.
Exactly. That also means that the Spark drivers works on Astra. Everything's related, exactly, because the Spark drivers wrap the Java drivers at this core, and that explains why it works.
Yep, absolutely. So let's go ahead and launch Astra. So Astra, I have my own instance ready to go, and I'm just going to bring up my database manager. I can just log into. I have to go to my astra.datastax.com, and yep. Yeah, I wish you guys had that when I was testing it. So I have a really old account. I should probably connect. I like signing in with GitHub. I love signing single sign-on. I don't really want to remember another database. So when we bring up the Astra dashboard, you'll notice you have the ability to have different databases. You can have different organizations. I have a free tier. Just remember that if you don't use it, DataStax will automatically park the database. Parking means that it's just turned off. So whenever you come on, if you haven't used the database, you got to unpark it. So right now the server is running, and once it's running, I can learn how to connect to it by clicking here. It's going to give me the endpoints. It's going to give me the environment variables I need to connect to it. The way we're connecting to Astra for the work that we've been doing is via
the drivers. Yep.
And we have to download the secure certificate bundle.
Yes.
And when we download it, it's just a zip file. What we do is we upload that zip file into our Git pod, and it's really easy. You just kind of drag and drop it in there. And I've already done that. I'll show it to you. But yeah, that's the common. Yeah, go ahead.
Yeah, no. So one might ask, why do you need to download a zip file? Whereas when I log into Cassandra, I'm only providing IP port and user password. Well, now you are using the cloud, so we want to create a secure connection between you and I, two-way authenticated using strong authentication and certificates. In the zip file, you do have the certificate needed to open that two-way communication with Astra. And then we use some technical tips and tricks to do the same load balancing and distribution of the load you use with the Java driver, but in the cloud environment.
Yeah, and there are probably any Cassandra application that you use today, you can port it to use Astra as long as you make sure your connection is using this zip file. That's really what it comes down to.
True.
We have code in Node, Python, and Java in the code that I'm about to show you, and Spark as well. And the Spark connectivity is basically the same way we connect to Java. Right? We have to give the same information, and it actually is really easy. I initially was like, oh, I thought the same thing. Cedric, I was like, oh, I have to download a zip file, but it's really not that hard. if you're doing any secure connectivity with Cassandra, you would need to have a cert file anyways.
Yes.
Right? So this isn't really that different. So we have the Astra up and running. Just to kind of revisit what we're trying to do before we go hands-on. So remember, we're trying to take these APIs and make them event-driven. We did that in the last session. What we're doing today is we're going to focus on this engine right here. And we're going to do two things with this engine, which is we're going to take a stream of basically events, meaning new resources coming in, new URLs being curated, and we're going to save it to Astra. Well, Kafka Connect and these other tools we've built before already save it to Astra. What we're going to do is we're going to parse the same event and materialize a table called leaves by tag, right? So in Cassandra, if you do the data modeling course, you'll know that depending on how you access data, you can create a table. So we have a query table called leaves by tag, meaning give me all the URLs by a particular tag. In native Cassandra, technically this particular type of query, we could put a secondary index, or we could put a SAI on it. But normally these things have their limits, and I think the SAI is much more performant. But currently, Cassandra 3, Cassandra 4, they don't have the SAI. So assuming that we're going to be using the core Cassandra technology here, more than likely, if we're going to go to production, we would end up using this until we test the SAI, or we would materialize the information in Solr to get these tag counts. But we have a table called leaves by tag that gets materialized in sync, in real time. And there's another table that we're going to create, which is called tags, which is given the tag, give me the tag count, right? So you can imagine one of those. It's easy to say, here's a new URL. It has tags already in there. I need to just save and update this information in my leaves by tag. That's one use case. And that can happen on a real-time basis. But if I need to update my tag count, right, and we have a bunch of different sources and a bunch of different streams coming in, it probably makes sense to read all the data and understand what my true count is and then update my tags, right? And that's what we're going to do with the Spark batch job. You saw this before. This is the stream process that's going to pick from the broker, save to leaves by tag, and then this is the process that's going to read from Cassandra, do some crunching, and then save it back to Cassandra.
I think we do have a question on the previous schema. What is a tag tail? Maybe that's features on your schema, right?
It is. It's you'll see it. I'll show you the schema when we bring up the DataStax Studio. So there's basically only 3 tables. We're dealing with 3 tables in this example. One is called URLs, another one's called tags, and one is called leaves by tag, because internally we call all of the URLs leaves. You'll see it, and I think you'll understand. It's just like, if you had a WordPress blog, right? You have tags and categories. That's what it is. It's just a tag to organize the URLs.
Okay, a business concept in your use case then.
Yeah, exactly. So anyways, if you haven't signed up for Astra, the only things that you need after you create the Astra database is really, your database name, your key space name, your username and password. Remember, because you have that certificate, even if I show you my password here, you won't be able to get access to that database without my secure certificate bundle. Since I've already made the database in the previous workshop, I'm not going to go through this exercise again. But if you look at the nice work that my colleagues and Cedric have done, there is a really, really amazing step-by-step, screenshot by screenshot process on GitHub on the Cassandra.api repo, which shows you how to get started. And actually, I don't even think you need it. Like, if you've used any cloud service, it's pretty self-explanatory, right? Create an account, make a new database, fill out some forms. If you're starting off, you're going to get Google Cloud, as Cedric mentioned. You make your database, you give it some things. It's standard. I don't think it's that complicated. In fact, the newer interface gets better and better and better every time I log into it.
Yeah, so we changed the UI a little bit. You shouldn't be lost, You should have to, you should provide the database name, the key space name, user and password, pretty easy. And then you need to pick one tier, pick the free tier, and then pick a region. And if you select the free tier, you are limited to Google, I think, Google Cloud. So
Yeah,
now you do have
that's
two
right.
regions, US West, Europe West, or US East.
Yeah.
And boom, you can pick the one you like to reduce latency.
Yep. And what other stuff do you get on Astra? It's not just the Cassandra database. We're going to be using DataStax Studio. There's also a way to get access to CQL SH via the browser. There's a Grafana dashboard to see some basic metrics. So that's all built into the Astra interface. So just like a quick view here, right? I can say Launch Studio. And this is kind of like a tightened version of DataStax Studio. It just has Markdown and CQL aspects that if you have DataStax Enterprise, there are some other things you can do like Gremlin and Spark SQL. But basically, it's a notebook interface to set up tables, like if you wanted to create a schema or to do queries, and we're going to come back to this. The other really cool interface here is your console, which you can also connect, if you wanted to from your own machine. But if you're learning Cassandra, describe.
And so at the same time, we had a question from Arjun, like, we keep saying Astra is free and everything, so you're asking, okay, about anything special about the paid and premier tier then? I like the question a lot. So with the free tier, you are limited in capacity. I mean, you do have a couple of nodes, and so you're limited in space and throughput you can achieve. Whereas if you jump to the premium mode, now you do have the capacity. You would pay for capacity, pay as you go, and you can have as many nodes as you need, and even have advanced features like VPC peering. If you already have nodes running somewhere, you can pair those, like VPC peering with the three cloud providers, and much more. Free tier is really wide, but not everything is open.
Yeah, and like I look at Astra, and DataStax is doing a tremendous job of basically open sourcing the different components that run Astra. Like Stargate, you can download Stargate, which is the REST and the GraphQL API. You can download Cassandra because Astra is basically Cassandra on Kubernetes being managed by DataStax. So you really have to do the cost benefit scenario, right? Do I really want to set up a Kubernetes cluster and Cassandra, and I want to bring up Stargate, and I want to do I really want to do that? I'm a Cassandra expert. All right, I don't want to do that. Because right now for this project that we're showing, it's a real project, right? Like if you go to Cassandra.link, this is a real project that runs, and the site is generated, and it gets a good amount of traffic. We don't want to mention it, right? As experts, we're just focusing on finding the best content. So do I really want to be managing a database? No. Does anybody want to be managing a database server?
No.
I mean, no.
No.
Yeah, it's worth looking into. But the technologies that run Astra, you can approximate a lot more time and effort to do that. There's these resources. By the way, this deck and everything will be made possible. I made available on the GitHub repo. We'll link it there, as well as we'll have a blog post on anant.us. But there's tons and tons of resources. Just a quick thing: Spark even though it's open source, Databricks does a hosted Spark, managed Spark. It's kind of like Astra for Spark, right? And it's got a nice little interface and everything. It's really cool. And there's a talk that one of my colleagues is doing about how to use Databricks Community with DataStax Astra. So free, right? Check it out. But there are other providers for Spark as well. Amazon's AWS Elastic MapReduce basically is a hosted Spark. Azure HD Insight is a hosted Spark by Microsoft, and then Google Dataproc, more recent, is a hosted Spark / Hadoop. In fact, all of these are Hadoop / Spark variants. And those are not the only ones, right? So you can use Cloudera, you can use, I mean, there's so many different ways to run Spark, way more than I think to run Cassandra. IBM has a lot of good material on Spark as well, and they're a big supporter of the project. So check it out. Check out Cassandra.link. We have, as you can see, the only thing next to Cassandra in terms of the tag count is Spark and Kafka, right? So there's a lot of articles on Cassandra.link on how to use Spark with Cassandra. We're ready for the hands-on. It's going to be fairly quick because a lot of the stuff we had done before. We're just going to verify that our API is up and running to make sure that if we do a process, it sends it to the Cassandra API. It's going to work. We're going to verify very quickly Kafka to Cassandra. Does our Kafka Connect work?
Yeah.
The reason is that we want to show when we create events that the Spark will be able to pick it up, right? We're not going to do all of the Kafka use cases today. We're just going to generate some content. And then, if you've never set up Spark, this is just a suggested way of doing it on one computer right now. And the only reason we're doing it in SVT server is because I want to be able to make some changes to the code and then compile really quickly. You don't have to have an SVT server. You can just use SVT command line to build packages. We're going to see this in action, right? Kafka to Cassandra in Spark streaming. And then we're going to see this in action using Spark to read and then materialize data back into Cassandra. We're going to see this one picture again. These things, the registry, the broker, the REST proxy, Kafka GUI, they're running as services. Kafka Connect can also run as a service, but we're not going to do that. We're going to do a standalone Kafka process. Anything with a dotted line it's a process that we can start and stop. Versus these are going to be running all the time on this. And actually, I should have put in here the Spark master and the Spark worker too, but I'll update that later. The materialization, this is what you're asking, what is a tag? So currently, Kafka Connect can take data from Kafka and save it to Cassandra, and it uses CQL to update this. Other code in Cassandra.api writes data to this table directly. You can also use a producer to consume from Kafka and send requests to Cassandra.api. There's an example for this, which then populates via REST, and then that uses CQL. And then Kafka streams can read from the queue and then populate via CQL as well. So this table already exists in Astra right now. So if I go to my DataStax Studio, and there's probably like a couple of thousand in here, but even this limit statement isn't really going to help me much. It's gonna do a table scan. Normally you would never do this, right? Because our primary key is it's not included in this query. But this data is you can look at it in like JSON view or right. So this is the data that is inside the table that I'm looking at earlier. Okay, it already exists. There are other tables that we will recreate because they already exist because I ran our streaming from Kafka. And while one process writes to this, another Spark streaming process can be continuously updating the leaves by tag table. What does this table have? It basically has, given a tag, show me everything that I need to basically populate a web page, for example, right? Show me the listing of all the articles for this particular tag. And if you look at the columns for this table, right? It actually has a couple more things. It has a title, it has a URL, because for that view, that's all we need, right? To show that particular item on a page, this is all we need. We don't need to we don't need to copy everything that's in this main table into the leaves by tag. The Cassandra, so this is another table called tags. This is the one that's going to read from Cassandra. It's going to crunch it and it's going to save it back. All it's really saving is, given a tag, it saves the count. So we can do a very quick query, how many, like the query that you see on this web page right here. The great suspender has suspended my page.
Yeah, probably.
By the way, great plugin, makes Chrome much more usable if you have 1,000 windows. But like right here, this listing, right, is coming from a database, a MySQL database. We're just doing a query, right, group by and count and all that. But in Cassandra, we can't do a group by. We can't do a count and a group by. So we have to materialize this table as well. So that's just kind of what it's going to show. Whereas the leaves by tag could potentially power this interface right here. So give it a tag, right? Show me the title, show me and give me the URL, and maybe we have to put a couple of other things in there. But that's kind of what we're doing. We're using a real use case to make these tables. Go ahead and start up my Git pod. It's normally, if I've started it once, it doesn't take that long. Give it a second. While that's happening, just to quickly review the Git pod IDE. You have an editor. It's connected to a Git repo. And if you pay for Git pod, you can connect to private repositories. So you can use this for your projects for work. Again, with github.com. Any open source repository, you can pull and use Gitpod to test it out, to play around with it. You also have the ability to start terminals, bash terminals, and run services. It can then expose the URLs that are like port 8000 or port 80 on a special URL that you can test. So anything that you can imagine you're doing in a local host, you can basically do on Gitpod. The only thing that we found that you can't do right now is you can't run Docker inside this container, because this is a Docker container itself. There's theoretically a way to do this where we load it with Docker, but if you find this person named Free Time, I'm looking for him, right?
Yeah, and also, so not only you do have the full IDE with all the VS extensions available for you, but Java is pre-installed, Node is pre-installed, Python is pre-installed, so that's pretty powerful to dev.
Yeah, this particular real-time repo is little heavy because we've got Kafka, we've got Spark on it.
Just a little.
Just a little bit. But it was kind of the only way to make it as simple as possible, but not simpler, right? Otherwise, we would have to have you start another Gitpod repo to run Spark, and so that would have been a Charlie. So what I'm doing right here, right, as this thing came up, these services got started, I'm making these ports public, right? These are the different ports that I can make public. I don't have to make all of them public. I'm just making them public because I want to, show you what I'm doing here. So what happened when I started this Gitpod container? Kafka started up. That's really what happened. That's why these ports are open. And I'm going to start something called AKHQ, basically to give me a GUI for Kafka. So the first and foremost, what we're going to do is we got this up and running. This thing can take time. It doesn't have to be up and running immediately, but we're going to go and start up AKHQ. What I like about AKHQ is it's free. It can work with basically any Kafka. So you can use AKHQ to talk to managed Kafka service by Amazon. You can use it to talk to Confluent. In this case, our Kafka instance is kind of a Confluent Community Edition, and it's going to be used for just looking at and seeing like what are the schemas in there. What are the the topics. Can I look at the message inside the topic itself? So if you've done this before, you can fast forward to, we've already gotten this running. I'm just going to quickly check to see, is this actually running?
So because it has been started at load, I mean, there is a gitpod.yaml, and you simply said, I want everything that's running when the instance just started.
Yep. And this is, I believe, right.
It's green. Up, 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 up.
Yep. Right. This is my gitpod.yaml. It basically says, go ahead and start Confluent. Right. It also cleans my Scala program, so I can then recompile it. I don't necessarily have like old packages in there, right? That's what I wanted to do. So we got Kafka running, right? If I wanted to force it, I could start it, but it's already working right now. Let's see if my previous work shows up, which is when I run AKHQ. So I'm going to open this up, and it should come up pretty quickly. It's a nice little interface.
Yeah, so it used to be called Kafka HQ, but probably due to the Apache community not fun reusing the name, it just HQ
trademark. Yeah, exactly. So at the very beginning, when Confluent starts up, right, it has some topics built in to run Kafka Connect. Basically, this is what it's for. But there's no actual topics in here, so we really have to go and just quickly create our topics. We're going to be creating a topic using a schema, using Avro. That's something we covered last time. The reason we have a schema is that without a schema, we cannot do structured streaming. And without a schema, we cannot do Kafka Connect. We need to have that. And without a schema, we can't do this, the REST proxy either. It's kind of like a must-have. You can get into an argument about whether or not we should have schemas in Kafka with somebody else, because I won't have it. I'm just going to tell you should have schemas. So what I'm doing is I'm just listing, right, the topics, and I can see now that there is a new topic called record leaves Avro. This is what I've made, and it works. It looks like it's working fine, right? Then I want to do is I want to create a bunch of messages. The requirements for this should already be there, but I'm just going to make sure that we still do it anyways. Okay, it's already done. Good. And I have a simple Python program. Sorry, I do need to create a schema. I just created the message. I have not created a schema. Now we have a schema. And if I see what I have, I don't have to go to the command line. If I just refresh,
yeah, so could we drop the PDF of the slide after the workshop? It's in the repo. It's not there yet. So I could put the PDF somewhere, but that would be probably better simply in the repo. Just get asked.
Yeah, we can put it in the repo, or usually what we do is we'll put it up on SlideShare, and then just embed it.
Sounds
and
great.
Yep. So we've got a schema, right? Everything we verified that it exists. We checked via AKHQ, and what we have basically is a way to see messages as they come in. That's why I like AKHQ. I don't have to have like another consumer to look at it. I can actually see a live tail of what's happening. And let's go ahead and run some import process here. So let's go to, I'm going to do a live tail. And I'm going to check out this here, right? Do like 50 messages at a time. And if I run, so what this is doing is it's reading from like a JSON file and it's making a bunch of sample messages, and it should be showing up here. I don't know why.
So that's simply a loader of your topic written in Python.
Yeah, that's what we're doing, just kind of loading data into the queue. We can take a look at over here. So notice that we have the data populated in 2 different topics. This one is with the schema. There's about 1,000 in there, right? And if I wanted to go in here and dig deeper, it takes a second sometimes to load it, but I can see my actual messages, right? What did I send here? And now it's done. So there's 1,000 topics in here, and we know that they're in here because AKHQ is telling us. Now what we need to do is to take this and send it over to Cassandra. So how are we going to do that? We're actually going to use the Kafka Connect because it's the easiest one. Kafka Connect setup is fairly simple. You can read it from the last example. But what I like about Kafka Connect is all we needed to do was make a schema, and given the bundle, the secure bundle and authentication, all the work I had to do in Kafka Connect to make this work was say, here, I'll find it. I needed to say this thing is equal to this thing. This thing is equal to this thing. This is the mapping that I made in Kafka Connect for it to take the data from Kafka and to save it to Cassandra. You'll notice when we do the Spark aspect of it that this is the same topic we're going to read from to save the leaves by tag. And to start up Kafka Connect, we're going to bypass some of these other ways of doing it. As I mentioned, there's a lot of different ways to do this. And we've already done this work. We've already done this work. And go in here. We don't do that. We just need to start Kafka Connect.
So as you can all see, this is simply copy-paste commands. So you could do that. Take your time. Don't expect to follow with us live, but the stream is recorded. You can go at your pace, but it's free. Go there, copy-paste, try by yourself.
Yeah. We're going to stop the service, Confluent Connect, Kafka Connect, because we're going to do a standalone service. There's a way to have this process running all the time. So as data comes in, you can automatically always save it to Cassandra using Kafka Connect. But because I wanted to have some control over this and be able to shut it down, I'm just running it standalone. So this is Maven doing some basic compilations. And there's going to be some errors. Don't worry about it. All right, so it's up and running, and it's committing a bunch of because we didn't consume the previously inputted data. It's basically running some processes. If we were to go to Astra, we would see, it's actually, I'm curious to see if I go here to help.
So was Kafka Connect started before, or did you just start now?
Kafka Connect was started.
So as soon as you push stuff in the topic, because Kafka Connect was there, it was ready to push that data somewhere. So you define what we called a sink, which is here Astra, and boom, now Castra, Castra. That's a nice tool. Castra. And now Kafka Connect on its own is really pushing the data into Astra. There is no extra stuff yet, no Spark involved yet.
We're just testing to make sure that Kafka is able to do its job, and basically we can send data to it and we can retrieve data to it. And right now there's like 17 clients connected, and that's because Kafka Connect is using a bunch of different connections to save data. It's gonna do as much as it can. So Kafka Connect is pretty powerful. If you just want to land data, right, from and to, it's perfect for that. You don't need Spark for that. So let's give that a little bit more time. It will tell us in AKHQ. Oops, wrong topic. So, actually, another place we can take is the DataStack Studio. So what we're going to do is we're going to do a count.
No.
I know, right?
Use Spark to count.
Yes, true. So we had about a couple. I think yeah. So it's kind of too long, right? It's going to take too long to do it. I believe I don't really have a way to change the timeout here, but that's okay. Let me see, and I don't want to try my luck and do it on the console. So just give it a second. Once the data shows up in Cassandra, because this data is in the Kafka, we can potentially drop our data and then recreate. Okay, so what I'm going to actually do is I'm going to truncate table URLs. Okay. Oh, we don't need the. Okay, good. And then let's see what this count says. Okay, so there's 0 data in there, right? And I'm going to go back here and I'm going to produce some messages. I'm going to open a new terminal. And this is the same way we're going to produce messages when we start up Spark, right? Meaning we're just going to use a Python program that we had earlier and just populate the heck out of it. And this data importer is pretty simple. You can take a look at it on your time. All right, so we're going to create a bunch of messages. And Kafka Connect is running, right? Now it's going to start taking some tasks. And in the meantime, let's see. Wow, look at that. 1,000 items in like less than a minute. Boom. Right? So that's how we're going to create messages. Let's go back to our README. So we verified that Cassandra is up and running. We verified Kafka is up and running. We verified Kafka Connect is doing its job, right? Now we're going to start doing some Spark. And we just basically did this. We have already downloaded Spark, right? Like what we did was download the latest version and untard it. I'm not going to do that again because I don't want to mess up the installation. But what we see here in the Spark directory, if you get the Git pod, you normally wouldn't have this folder for where it shows Spark, the Spark bin Hadoop. You wouldn't see that. So we did that already. The next thing that we do is we download SBT. Really, SBT is used to compile Scala programs. You don't have to use Scala. You can use Java and you can use Maven to compile your Spark jobs. I'm using Scala. I'm using Simple Build Tool. We have already made these tables, okay? But just so that you believe me that this is working code.
So add if not exists somewhere, I don't know.
Yeah, right?
Oh, be careful, you might truncate again your URL table.
I mean, I don't know what's wrong with that. Okay, good. And then tags. So here, if I go and check out what's, nope. All right, so I can just do this. I can just say drop table tags, I believe. Yeah, that's what I was missing. I was missing the table.
Yep.
And drop table leaves by tag. And this will update. Look at that. It's gone forever. No, I'm just kidding. So we're going to make these new tables, right? Where we're going to materialize our information. And we're going to start our Spark master. What is a Spark master? Spark master is kind of like the commander for Spark. You give it basically. By the way, we're stopping Kafka Connect because we don't need it anymore, right? We already have Kafka data in there. But the Spark master is just like the commander, and it takes requests and it plans out and it delegates the work to the workers. So when we start the Spark master, we actually get a port that we can view kind of what's happening. So right now there's no workers, right? We don't have any live workers. We don't have any cores available. We have nothing available. But the Spark master is up saying, I'm ready to accept new workers, right? And so we got to add a worker to it. And what we need to do is we have to go in here and get the URL for the Spark master, and basically start the slave and say start slave master, and then give it the master URL. If you're using other technologies to run Spark, you don't have to do this because it's kind of part of that package, right? Important note here is there's a lot of different tunings that you can do with Spark in the code, in the configuration. And in the configuration, you can give it like how many executors to use, how much memory per executor. But I'm not going to cover all that. That's, as I said, you could expend days on end talking about Spark. But it's important that you cannot use more resources than you have, right? So in our case, when we run the job, it's going to use as much as possible. But if we say, hey, this streaming job only started with 3 cores and use like 1 GB each, it's going to use up basically 3 GB and 3 cores. And then we can start another job. So Spark isn't just a single tasker. It can run multiple processes. You just have to have enough resources, right? And that's why it makes it powerful, because you can have a very, very big cluster, right? And with like thousands of cores and terabytes of memory, and you can say, run this Spark job, run that Spark job. And depending on how big the job is, it'll get spread out and it'll get executed. If we go back to the worker, sorry, to the master, if I refresh, you'll see that that worker is now registered with this much available resources, right? I don't have enough resources on this Git pod to open up another worker, so I won't.
That's still a lot. Remember, Kafka is running in background, including connect.
So we're going to start the Spark, the simple build tool. I like having this utility to quickly recompile, as I make some changes. You don't need to do this normally. Like, you don't have to have a Spark build server. So this is our Kafka Connect. I can go ahead and stop this. All right, we don't need this anymore. And let's see. Let me go ahead and paste. There we go. And all this SBT server is doing for me is giving me the ability to say assemble, Avengers assemble, right? Now, it's compiling. And the beauty of Scala is that when you say SBT assemble, it only goes and checks the Scala files that have been changed. And it's a little bit more elegant, I think, than Maven. Like it does much faster. In fact, I don't know how to explain it, but I read about it before. It uses Scala streams internally to basically build its own software. So it's starting up for the first time. It's getting the basic repos from Maven, right? So Scala is a JVM system. That means that anything that's on Maven, anything that you have access to on Maven, you can get. Right, so we got it. And there's a couple more things that we needed for Spark, so it's downloading that. And I'm making a what's called a fat jar. Okay, you don't have to make a fat jar. The reason we are making a fat jar is this jar has everything it needs, so I can send it to any Spark server and it'll work. If that Spark server had all of these libraries, then my jar would not have to be that big, because I don't have to package my own Spark connector driver, right? So this is just a way to ensure that my libraries that I need are going to be in that jar that's going to get executed. If you're not familiar with what a jar file is a glorified zip file. It just ends in .jar. It's a way to package everything that executes in code into one jar file. We have a properties configuration file, which I edited earlier, but it's really just a way to configure the Spark job without doing it on the command line. But everything that you see in this properties file, you can send in the command line. Like you can say, use this different file for my secure bundle, use a different username and password, and if you can imagine, the same Spark job could be run against different Cassandra servers, different Cassandra key spaces. So this Spark master needs to be updated because we potentially have a new Spark master here. It should be the same because I'll double check though. Yeah, it's not the same because I've started a new master. And now we're ready. We're ready to run code, and I'm gonna actually, oops. All right, I don't need an SVT server anymore. I already compiled what I needed. So I'm gonna run my first Spark job, which is leaves by tag. And be careful when you copy and paste this. You have to give it, you don't have to give it, all of these parameters. But I wanted to show that you can always override the conf file with whatever is in the conf file with your own setting here. So copy, paste. I'm just going to quickly paste it here. I'm not going to save my file. And I'm going to change this to my name of my database, right? It's called platform. And what is this doing? Spark submit is saying, run this class, and we'll take a look at that code, using this properties file. And by the way, take a look at the zip file, because that's where my secure bundle is. And my stuff is in here. My stuff is in this jar that I created earlier. So, got that ready to go. Let's take a look at the code. So if you go to the Spark Cassandra directory, you'll see in the source directory, Scala, main, blah, blah, blah. This is just funny business in Spark and Scala, but leaves by tag is a very simple program. Yeah, we need all this stuff to kind of connect to Cassandra, but what is it doing? It's connecting to Kafka, and it's making a data frame. Remember when we talked about data frames? It's like a database in memory, and we're using structured streaming. So what's really happening is we're populating this data frame with the data from the stream. And then when it's in there, we can then select data from that data frame. So what this is doing is saying select data tags as tag, data.title as, this is SQL, by the way, right? And we want to explode this into kind of our own map. And it gets this data. And once we're ready, this data frame, which came from this one, we can basically say, write that data back to a table, into this table, into the Cassandra format. And that's it. We populated this. We will populate this topic again. This code is going to read it and transform it in flight into the structure that we want in our table, in our Cassandra table. And this code will write it. Okay? So, copy and paste. Oh, I need to be in a different directory. Because I'm running Spark submit, right? So I need to make sure I'm in the Spark folder. So when a Spark job works, when a Spark job is running, it will also have its own UI, which kind of tells you what's happening, right? So this job basically is running. It's a stream job, okay? And basically, like I go to the master, I can then go to the worker, but I have to use the worker URL that I have from Gitpod, because this is using kind of an internal reference. And then on that worker, I can see essentially what is happening, right? So up until now, we haven't really created new messages. So our job is running, okay? It's kind of doing its thing. We need to give it some new messages. And we can do that. Go back to my handy Git repo. And send some more messages. So my handy dandy Python importer is just populating the topic. In the meantime, my Spark job picked up these messages, right? And it's transforming it, and it's writing to that table. And if I refresh my jobs here, so you can see it did some stuff.
Does it mean the same data is read twice, one from the connect and one with Spark and written in another table? Is it the same data that you process in both cases?
I'm using the same data. And actually, it's a good point, Cedric, that if I wanted to, I could have just set the offset and replay the same data.
Okay.
Yeah, but it's right now, it's effectively the same data, right? If we had the Spark job running at the same time as the Kafka Connect, both tables would have been populated, because Kafka Connect is populating one table and this Spark job is populating another table off of the same topic, essentially. So we have the Spark job. It shows it's running. Let's take a look at our DataStax Studio. And what I want to do is see if there's any data in here. So, well, you saw me delete the table. So if I do a query,
yeah,
hey, look, it found some data, right? There's some data in there. Awesome. And if I want to see the actual data, this is what it looks like. Right? Given this particular tag, here are the 43 results. Okay. Now, this is a much faster query than to say, select star from the main table where tag is equal to whatever with allow filtering. Like we should never do allow filtering, right? And our goal with this table was to have a fast tag article lookup. And then lastly, as we come to a close, we have another job that we want to run to populate the the tags table. I'm going to go ahead and stop. And my last job that I'm going to run is, we just verified this, right? We got the tags. We run the second Spark job. And so similarly with the second Spark job, I'm just going to quickly examine it, make sure that I'm using the right zip file. This Spark streaming job is being stubborn, but I'll show you a way to kill the job with the UI, with the Spark UI. We didn't talk at length about the Spark UI, but the Spark UI is an excellent place to start to see how your Spark job is performing, what parts of the Spark job are taking too long, to basically better break up the work, right? So this is let's go back to the Spark master. There we go. I'm going to actually go to 8. Oops. Sorry. All right, so this is my Spark worker. And I'm going to go back to my Spark master. And, looks like this application finished, right? Did its job. But still thinks that it's doing something.
In Kafka, I cannot say Kafka HQ, but AKHQ, so you can browse the topic. Can you see the consumer and the topic, the offset where they are, just to see if they may have consumed or not?
Yeah, actually, it shows you the offset.
Okay.
And it shows you which consumer groups are attached to it, because it registers that. So it's gonna be a second, but I'm gonna run the second Spark job. Going to populate the second table. And I had it right here. Yep. And if I go back to my Spark master and I refresh, you see that now there's a new job, right? And this is what I was showing. Like if an application isn't dying on you, you can always kill it. I think I have a runaway process on the other one, but that's okay because the master is not kind of dealing with it right now. This job should finish pretty quickly. What it's doing, by the way, is it's reading the data from Cassandra, and it's then rewriting the data. Okay, there it goes.
So that's pretty cool. So here you do have two different jobs. First was Spark streaming, reading from Kafka, and the second was standalone Spark to read from Kafka, read from Cassandra and back to Cassandra, which is two good sample code for you to start building Spark jobs.
Absolutely, and you can see that this one took 34 seconds. So what Cedric was talking about, right? When you do Spark SQL, just be ready that sometimes the Spark SQL is getting made into a Spark job, and that Spark job is getting executed. Depending on how much memory and resources you have, it may take a while, right? It may take a minute, but it'll come back. It will finish the job, and it's a heck of a lot better than Hadoop. That's for damn sure.
That's for sure.
For sure. There we go. The Spark streaming job also disconnected properly. The tags code, which we just ran, the batch code, to show you, a lot simpler than the leaves by tag because it's actually reading from Cassandra and saving back to Cassandra. So what we're doing is we're saying, hey, get all of these tags from my main table, right? That had 1,000 URLs. And I want you to make a different data frame, basically that gets the tag, and then it gets the count. And I want to save that data frame back to Cassandra. And so that table gets materialized in Cassandra as this table here. And so if we do a select star from tags, where tag is equal to Spark, we'll get the same thing. And because this is a small table, you can just do select star from tags. So it went through 1,000 items in Cassandra. It read all of that data, right? It counted them, and it saved it back in 34 seconds. Right?
Pretty cool. You know, even with the free tier, you do have some power.
You have a lot of power with this. But that's Spark, you know, in a nutshell. What you can do is talk to any system, and obviously you want to talk to Cassandra. You can read from Cassandra, you can write from Cassandra, you can read from Kafka, you can write to Cassandra like this. This is the latest and greatest, you know, using structured streaming and data frames. Older Spark code is not this elegant. It is not as cool. This is as close as it gets to select star from this table, insert into this other table, right?
Yeah.
We can do in SQL. Spark is as good as it gets.
Yeah, so I think it's time for a question I got some hold from Smita from a couple of minutes now, even hours, is, so we pick Spark streaming. Why not Kafka stream? What is the difference, and which one should you use when?
Perfect. That's a really, really good question. So Kafka streams, by default, gives you access to all of the topics. And it can even show those, you can kind of even do a little bit of joins in between tables, right? But your data has to be put into Kafka first for you to be able to do stuff with that data, right? Kafka Streams also assumes that you're operating off of a topic and you're going to do something with that data. And yeah, Kafka Streams is, you can write a Kafka Streams job in Java or Scala or anything. And that's it, right? Spark is a much bigger ecosystem. So you're not just limited to the data coming from Kafka. You could have that data coming from Kinesis as a structured stream. You could have that data coming from SQL Server as a structured stream. And then that data frame that represents the Kafka topic and that represents the SQL Server topic, you can do joins on it. You can do manipulations in those between those data frames if you wanted to, and then you can save that to Cassandra. So that's one thing that you can do with Spark. The other is, by the way, you can also kind of do that with Kafka Streams, but you wouldn't get a data frame of the SQL Server table, right? And you wouldn't necessarily get a structured stream for other stuff. The other thing that Spark has is compute. It can do massive amounts of data crunching. So if your data comes in a topic, you can then essentially parse that data. You can transform it. You can enhance it. You can evaluate it for machine learning. If that process is going to need more power than one computer, then you can use Spark. If that process is going to take more than one computer in Kafka Streams, probably not possible. You have to kind of break apart the work differently. And then finally, I would say, like, to differentiate the two, if you know your whole workflow is in Kafka, like every single thing, you can kind of do everything in Kafka Streams. Only when you have to do big, like, batch processing, then you would use Spark. You wouldn't necessarily use Spark streaming for that if you have Kafka Streams.
Got you. Great answer. Yeah.
Any other questions?
I mean, I did a good job answering all the questions, I guess. It was, pretty deep dive and also step by step, so people can follow along. And so we will share with you all the resources, and you can see that you can do it on your own, and with Gitpod and Astra there is nothing for you to install or to pay or to provide any info. Just watching for question. Oh, we had a question about Spark. Would you use Scala or Java? You know, I used to be as well a Java. I'm a Java hardcore programmer, and when it comes to Spark, really, I'm stuck pretty fast with the data structures they manipulate. You don't have the same flows. I don't know what you think about language war.
Sure. Yeah. So in Spark, I think the question is, which language to use.
Yep.
So, I actually have this up here on one of the slides, all the different languages. So let me just bring that up. So Scala, Spark is written in Scala, all right? And, there were features in Scala before there were features in Java, and they kind of eventually get parity. Ultimately, this is a company or team decision, because these are the two compiled languages. Well, maybe I have not tested against C#, but these are the two compilable Spark languages that can run the fastest, right? The one edge that Scala has is that you can do what's called a Spark shell, right? And I can kind of like start it by kind of a deep dive, a different deep dive. But basically, you can start a shell and you can copy and paste this Scala code and try it out without compiling it.
Yeah, cool. Oh yeah, okay, neat, pretty neat.
Right, right. So you can say, do this, right, and run this, and run this, and then run this again, and run this again, and so you can try out a bunch of stuff in real time in a read, evaluate, print loop that you couldn't do with Java, and that ability only exists in Scala and Python to be able to do it interactively.
Yes, okay, that's cool. Also, we delivered a fat jar, which I find is the easiest way to deploy Spark stuff in a dedicated infra, because it's a fat jar, everything in a single place. If you are using Spark R or Spark Python, it's more difficult to package and deploy. You can do the same, but when it comes to putting that in production, I felt it's a bit more difficult. The CI/CD is not as mature as the one for the Java Scala part.
Yeah, absolutely. What I find is the main workflow is that there's people from different backgrounds that generally will work on an analytics platform. So the data scientists will have R or Python on Jupyter, the Jupyter Hub, the web-based notebook. They'll try different things out. Then when they're happy with something, they will try Spark Python. And then when they're really happy with it and needs to be faster, they'll tell the data engineers to then make it in Scala or to make it in Java. But the same platform can support all of this, right? The same data sets, the same general APIs. You just have to change the syntax every now and then. Thanks so much.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.